All right, so for your project, you have several choices to choose from. So option number one is a just transformation situation. So go find yourself a logo. Perhaps you like the Chevy bow tie. I would do something with corners if it was me. So if I'm doing that, I'm going to go like Chevy bow tie. Um, let's say you take this guy here. Let's get a nice picture of it so that it looks better. Excuse me. Yeah, this one here, nice, beautiful, whatever. So if you save image, the reason I like doing it this way is because it's pointier. If you did like a Ford Oval, which I prefer Ford, not that it matters, but if I did that, what ends up happening is I end up having a hard time because it doesn't have any. It doesn't have any corners on it, and that's annoying. So this helps if you put the corners on because it helps you line everything up properly. Here we go. Sweet. So what you'll notice is these guys can be put anywhere. I don't want it at the origin. Okay, there they are. You can also string this thing around if you like. I don't want that fat. I want to start in the corners. Good for you. So what we're going to do is we're going to put points on all these other ones. And I forget how many I said, but it doesn't really matter. You can look it up and read it yourself. Boom. 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 So when I transform this thing, let's say I'm doing 5 of them, those 5 points, I should be able to go back then and line up my picture with those guys. Okay. So we're going to be doing some different kind of translations and whatnot to them. So it's a total of 5 points in the matrices. So in the matrix, you're going to have this. The matrix will be a 2 by 5 matrix in our case because the top row will be X, the bottom row will be Y. So you have an ordered pair right on top of one another. So in our case here, this point right here would be the point, and it would be 1, 2 in the matrix. This would be 7, 2 in the matrix, 1.74, 3.85. Okay. And so you'll be doing some transformations to that. So some shifting it about. Oops. We'll quit doing that. So you're going to do these. You're going to perform them using matrices. Okay. After each one, I want you to plot the new points and a copy of your image back on GeoGebra. Obviously not on the same screen. It gets really confusing, but do take screenshots of it, okay? So reflection over the x-axis. You can actually look up and find what you need to multiply by to get those guys to reflect over the x-axis. A rotation of 30 degrees counterclockwise around the axis. Sweet. Okay, around the origin. You need to translate it to the left and down 3. Rotate 160. This is important around the furthest point from the origin. Okay, what you'll find is the general rotation matrix always rotates around the origin. So if I want to rotate around a point, that means that point has to first be translated to the origin, then rotated, then pushed back where it came from. Okay, so just kind of keep that in mind. That's a 3-step process on that one. Reflected over the Y, some more translations, and then a dilation. Okay, now a dilation obviously means it's getting bigger. Okay, it's going to get 1.5 times its normal size, but it matters from whence you start. Okay, so if I expand out, if I dilate about a point, that point doesn't move. Okay, so if I'm going to get 2 times taller, if I dilate it off my tootsie, my front of my big toes, or my big toe rather, one of my big toes, then that big toe doesn't move. Everything else moves relative to it. That's important. If you did it with respect to your belly button, you'd be in the ground when you grew. So it's kind of important which one you're doing it around. Okay. Anyway, when you're done, then I need you to put it back from where you came from, back to where you started from. Okay. Now, because we did translations and reflections and rotations, translations are a different mathematical operation. If it was all multiplications, then you could come up with just a inverse matrix and get it back. This one is not possible because of its additions, a different kind of multiplication. And so, or different kind of process. And so you have to be aware of that. Okay. if you can get it to work in Python, I'd give you extra credit too. Okay. Again, I don't want you just copying somebody else's work. Do your own thing. Okay. Now, we talked about Markov chains in relative to Monopoly the other day. We saw that video. If you would like to look up about Chutes and Ladders, I know that's one that's been done online, or other games, that's fine. Or you can recreate your own. Okay. If it's something that's kind of hard to do, like, I don't know, I'm just making one up here, Magic the Gathering or something, and you're like, well, yeah, but, and it's going to take 7 hours to explain it to me, and the game takes 30 days to play. It's probably not a right game for this. Something like Chutes and Ladders, where it can get over with at 15 minutes. It'd be kind of fun to actually simulate that situation if you do. Excuse me. Again, if you try to use somebody else's, I want to see the work that's done. I don't want just straight up copying. I want you looking and explaining it. And I'll be asking some serious questions as we go along. Okay? Right. If you do your own, I'll give way more leeway and grade it. Now, option 3, you need to go on and read about error detecting and correcting codes, and specifically Hamming codes, and how to do them with matrices. Okay, Hamming codes aren't the only one. For instance, a VIN number is a code that is a really bear cat because, like, for instance, back in the 80s, Ford trucks had 3. So the 8th digit was the engine code. And you either had a Y, an N, or I forget the other number. And that would tell you one of the 3 engines that they had. But then when you do a VIN number, you take that, let's say N, and you then that correlates over to being a 7 or something. And so you have to do the math on it. Okay. So that's but it definitely is a detecting code, because when you fat finger something and then you hit a B instead of a V or something, or you're listening and you think you heard V, but you heard B because whatever. Or one time I was ordering a part online or on the phone, and the guy asked me, did I say B as in boy? I said, no, P. And I could not think of a P word to save my life. And so I went, P as in, is it Paco? And my TA started laughing at me. I'm like, what? And she's like, Paco. And I'm like, it's the only P word I could think of. And she's like, and then she rattled off about 30 P words. I'm like, okay, show off, whatever. Okay, you're smarter than I am. But it's that idea that if you miss something, you type something in wrong, it will definitely, that is not your car. Okay, and it's not some other random car either, right? So it's not like, oh, I typed in a V instead of a B, and now all of a sudden I got a Cadillac instead of a Ford or something. No, it's ridiculous. It'll just say, no, it's a problem, go fix it. Ditto with UPC numbers, ditto with ISBN numbers. All those are codes. If you would like to do something with UPC codes, you're more than welcome to do that. If you'd like to do something with ISBNs, either the 10 or the 13s, again, you are more than welcome to deal with that. What I'm specifically needing you to do is use matrices to do this. Also, I want you to look into the cool thing about a Hamming code. The idea of it is it actually will fix the errors in real time. And so what you will see is that the computer has been programmed to encode data, send it out, so that when it's received, and it's binary code, when it's received as a string of 1s and 0s, you've actually added a few zeros to it. For instance, suppose you're sending, the classic one is a 4-digit one, but you're sending actually 7 bits. And so the other 3 are what are called parity bits. And so that when you program it, it comes back out. And if you end up with a matrix, so when you multiply it by one matrix, it encodes it into a, this is what we're sending out. And then when you get there, it'll take that and it'll multiply it by another matrix to decode it. And so whatever it receives, whatever you receive on the other end, you multiply it by a matrix. So, oh, by the way, let me back it up. You send out a vector. Okay, so the classic is always a 7 by 1 vector you send out with 4 bits of information and 3 parity bits, that is for checking. And so when you receive something, you receive 7 digits. The question is, are they the right digits? And so what the computer does is it actually goes through and multiplies by a matrix, and then when it spits it out, it will end up with simply 3 And so it'll end up with a 3 by 1 vector. And what that means is that if it's all zeros, yay, you receive the correct thing. There is no error. And if there's 0, 0, 1, then the error is in the third parity bit, and then you can actually track down which of the 4 from above is the problem. You can track it down pretty easily that way. And so you read about that. It's pretty cool. Yeah. So again, if you want to do something with looking at how you can use UPC codes, but specifically I want you to concentrate on the Hamming code. And then again, if you can program that to auto run it. So let's say I want to send the bits, let's say 1111. Yeah. How would you encode that? And then when you got back, how would you detect it, right? And whatever. So then kind of work through that. Just a second. Anyway, I don't want you just doing the 4 bits with 3 parity bits. I would like you to also look into what would that take if you were to take it to the next level. I am fairly familiar with this stuff, so please don't get up there and just start spouting off something on the Wikipedia page or whatever, because I'm pretty good with this stuff as far as how the math works. I would like you to explain it in your presentation. The reason this works is because da da da. Okay, I would do the 741 to describe it. And then once you do that, then we can talk. If you want to, then if all you do is a 741 but you do a Python code to go with or something, that'd be pretty cool. If you want some real points, all right, you need to make up some points. You feel like you need to make up some points. I'd like to see you do the next one up, which is, I always have to look it up because I don't remember off the top of my head. The 11 data bits and then the 4 parity bits. Okay, so if you want to try that one out, I'd be more than happy for you to do that. Okay, and yeah, so what'll end up happening is you guys are going to make a presentation. You're not going to make back to it. Next week, because we're missing this week, next week in class, you don't have to make the presentation in class. I want you to go ahead and do a screen capture of yourself making the presentation, the video, whatever you prefer. Probably, if I was saying, I would do it off a quote unquote PDF, right? And you just voice over it, explaining what's happening, what your work was. You don't have to you don't have to present in class. You'll be uploading the presentation so that I can look at it at my leisure at home. Okay.